Hi everyone, welcome to another linear algebra tutorial. In this tutorial, earlier on in the previous tutorial, we have already learned how to derive the solution set of the vectors using vectors and also in vector and using vector notation. So now we will want to see whether a particular vector exists in this solution set of vectors. So we are going to go through some examples to see whether a vector exists in the solution set of vectors. So now the first example is that the vector is in the set. What value of perimeter produces that vector? So for example, these are the examples of the exercises that we'll be doing later on. The one on the right, on this side, are the vectors. And the one here, these are all the solution sets of vectors in vector notation. So, for the first one, we write the solution set as this. As you can see, here, from here, so we do our step xy equals to this, and hence we expand it as this. So xy equals to k, you bring the k inside a scalar multiplication, and then the k to the bottom. So this is scalar multiplication, so you get this. And now we got a given vector which is same as this. So it's 5 minus 5. So 5 minus 5 equals to k minus k. So from the first row, we can see that k equals to 5. And from the second row, we can see that minus k equals to minus 5, which means that k equals to 5. So since that the values of k is consistent on both rows, we already can confirm that the vector exists in this solution set, and hence the value of the perimeter, which is k, is 5. Let's go through the second example. So we are given this solution set here. So we do it again, like in this step again, and hence we get it in this form. So we do vector operation of scalar multiplication and vector addition. So hence we got it in this form. So x equals to minus 2i plus 3j, and y equals to I, and z equals to j, where I and j are the perimeters. So we are given this vector again. So what do? We plug it in here. So we get this equals to this. So now we compare the coefficients again. From the first row, so now we have this, so we know that the second and third row has I and j variables respectively. So hence we see that from second row, I equals to 2, and from the third row, j is equals to 1. Notice that, so now we plug into the first row to confirm whether that the values of I and j will match to be equals to minus 1. So by plugging it into the first row, we get this. So we get minus 1, which is same as this. So this means that the values of I and j are consistent. Therefore, the vector exists, and the values of perimeter are I equals to 2 and j equals to 1. Well, now let's take a look at the last one. So now we are given this solution set again. So what do? We do vector multiplication and scalar addition. So we get as this for x, y, and z. X equals to m plus 2n, y equals to m, whereas z equals to n. So we are given this vector. So hence we plug it in into this equation, we get this. And from the, so now we notice that the first row consists of m and n variables, and the second row consists of, second and third row consist of m and n variables respectively. So from the second row, we get m equals to minus 4, and the third row, we get n equals to 2. So by plugging it into the first row, we get 0, which is correct. So since the values of m and n are consistent, m equals to minus 4, whereas n equals to 2. So let's take a look at another examples. So the same. So this time the questions are different. So we want to see whether the vector is in the set. So these are our examples. You can take a look first. So again, the one on my left side are the vectors, and these are the solution sets in bracket here. So let's carry on with the first example. So the solution set of this, we write as in this, we express in this way, and we do our scalar multiplication. So we get this. So now we are given this vector 3 and 3 minus 1. So we plug it into this, we get 3 minus 1 equals to 6 minus 6k and 2k. So from the first row, we can see that minus 6k equals to 3. So k equals to minus half for the first row. And the second row, 2k equals to minus 1. And hence, you get k equals to minus half. And since the value of k are consistent on both rows, therefore the vector is in the set. Let's take a look at another example. So now for example B, as you can remember, this is the solution set as given. Hence, we do a scalar multiplication. Since there's only scalar multiplication operation allowed, so this is what it is. Since we are given this vector 5 and 4, so we plug it into this equation, we get this. So by comparing, first row we get 5j equals to 5, which means j equals to 1. And from the second row we get minus 4j equals to 4, which means that j is equals to minus 1. But look carefully. If you notice, the values of j are not consistent. Hence, we can say that since values of j are not consistent in both rows, the vector does not exist in the set. So now let's take a look at the solution set of this. From C, as you can remember, the solution set is written as this. So what we do, we apply our scalar multiplication and vector addition. Hence, we got it in this form. So now let's see whether our given vector shows that the values of R are consistent. We do again the same step, we plug it into this, and hence from the first row now, from the first row we get R is equals to 2. And from the second row, we get this 3 minus R equals to 1, which means R is equals to 2. From the third row, we get minus 1 equals to minus 7 plus 3R. And after simplification, we get R is equals to 2. And since the values of R are consistent on all the rows, therefore the vector exists in the set. So let's take a look at the last example, the solution set. And you can remember D, the solution set, is written as this. Hence, we do scalar multiplication again, vector operation. We got it in this form, which is easier to solve. And now we are given this vector. So what do? We plug it in, and hence, but you notice that the first and third row is quite complicated as it has 2 variables, and the second row has only 1 variable. So we start from the second row. So first, from the first row we get this, and the second row we get this. So we start from the second row, k is equals to 0, and hence we can do this. So we sub k equals 0 into the first row, we get 2j equals to 1, which means j is equals to half. So now from the third row, as you can see, from the third row, j plus k equals to 1. And now we just sub the value of j and k to see whether it equals to 1. So we add j plus k equals to half plus 0 equals to half, which is not equals to 1. So this means that since the values of j and k are inconsistent across all the rows, this means that the vector is not in the set. So now we have come to the end of this tutorial. In our next lesson, we will learn how to find the transpose of a matrix. That's all for today. Thank you.